So, as we mentioned last time that we will be starting a new texturing process, and this is going to be air jet texturing, and we will discuss this for a couple of lectures and understand what it all involves. So, till now what we have done is we have seen texturing, which is twist texturing of thermomechanical thermoplastic yarns, thermomechanical thermoplastic yarn. And in this we have done the draw texturing, friction texturing. What we have learnt is that the chemistry of fiber plays a definite role in thermomechanical twist texturing. So, twist was the mode of deformation, could have been false twist or any other twist method. Today we will learn something about air jet texturing, the definition, what type of a product is called an air jet textured yarn, basic processes involved in air jet texturing. So, you need a basic process. There must be some advantages, we might like to note them, and application of such type of materials, yarns and fabric made out of them is briefly we will look at today. So, if you look at a general definition, it may be said that it is a process by virtue of which bulk is introduced with the help of compressed air. So, bulk is introduced with the help of compressed air in an otherwise flat filament yarn. So, this flat filament yarn was still part of a definition that you have a filament yarn which got multi-filament yarn, got a large number of filaments, and you are going to be using some compressed air, and we hope to develop bulk. So, what would it mean? Probably some kind of a structure, some structure like this. There are loops, bends, curls, which obviously get introduced because you have some deformation possible because of the compressed air getting into play. So, you can see there may be some area which is little denser, some area which is lighter, and what we expect is that the compressive resilience of this material should be high. That you compress, the so called loops which are being seen will get compressed, remove the force, they would expand back, that is one. Also, we expect that the volume, the specific volume of the material which was called the filament yarn, flat filament yarn, which has been used, should have increased by a certain amount, specific volume, and therefore, we will consider this that the bulk is introduced. So, this is how you introduce the bulk in otherwise a flat filament which would occupy very less amount of volume. So, what about the stretch? They do not have any stretch, do not have any stretch. So, they are truly in the category of bulk yarns. So, as we are moving from the false twist texturing or a twist texturing, we are now getting into another type of a material which is called the bulk yarn. The one which was called a modified stretch yarn was a derivative of whatever was available in a stretch yarn. You are modifying this and trying to get it. So, principally there is not much of a difference except that you are giving second heat treatment. Now, this material is different. So, today we can have a relook at the definition. The process by virtue of which bulk yarns are produced, that remains the same. You have to do loops formation and entanglements have to be done. Again, compressed air has to be used, but you are not talking about flat filament yarn, it could be any yarn. You can have a filament yarn or you can have a spun yarn. Just today, people have used this air jet texturing process to increase the bulk of spun yarns as well. And spun yarns means they have fibers which are obviously short staple length fiber, but still you should be able to get an increased amount of bulk because of this process called the air jet texturing. So, it does not have to be a flat filament yarn. So, one interesting part of this is that this is basically a mechanical process. So, all the interaction that is happening with the fibers and the yarn is basically of mechanical nature, bending, loop formation, entanglement and so on and so forth. And in some sense we can say it is independent of the chemistry of fiber. It does not matter it is polyester, it does not matter it is a nylon, it does not matter whatever it is. In the previous case, we had difficulty in thermomechanical texturing of viscose and cotton. So, we are looking at a chemomechanical process being slightly different and complex. We were not very sure that we can do a good job with acetate, triacetate fibers or for that matter acrylic fibers, the filaments. But here we do not have that restriction. You just have the filament yarns and now we say do not have to filament yarn also. Take any yarn, just put it through this process and something definitely positive will happen. So, in some sense it is more versatile process and any type of yarn could be used. Of course, we need a compressed air and we need some active interaction on the yarn and some parameters obviously will have to be controlled and some characteristics will have to be observed to be happy that we have done a good job. So, you may have a yarn moving from one end to the other end of something called a jet, which is like a black box. You do not exactly know maybe what is happening. What you are doing is during this process the air is entering the jet, the yarn is also entering the jet. The thing that we may be interested in is how do we create a loop. So, maybe we would like to give between these two sets of rollers an overfeed. So, you give overfeed. That means you have excess length of filaments or fiber or the yarn. At the end of this process, we expect that this overfeed would have been taken care of and when the yarn comes out, which may be a textured yarn, would be a taut yarn, it would not be loose, lax. So, all that additional fiber filament length that is available would have been consumed in the process of creating loops, crinkles, bends and entanglements. So, you will obviously give that much overfeed which can be consumed. If the process can take about 20% overfeed, you will not go to 70% overfeed, then you may not be able to do the job. So, this optimization will have to be done, but process is simple. So, theoretically if you look at the history, this process of texturing should have been the most popular method of texturing, because it gives nothing except of course it does not give you stretch. So, if you are really interested in stretch, then obviously this is not the method. So, the three basic steps that must happen before a textured yarn is formed. One constraint as far as the understanding is concerned, remember, although we have used in our definition that spun yarns can be texturized, till we talk about spun yarns, we must assume we are talking about multi-filament yarn. So, the perspective remains clear. So, we have a multi-filament yarn, so which comes through a package. All the filaments are quite close to each other. So, the first process is separate them. You separate the filaments, opening the bundle. This is again quite important. It is an important step. Then loop formation. You are given an overfeed, and so filaments must be bent somehow, so that some loop is formed. And after that, you need to do some entanglement. So, that whatever loops have been created, they stay in their position. The whole thing therefore is how many loops can you form and how better is an entanglement. If entanglement is poor and you put under strain, all loops open, there will be nothing called a textured yarn, because everything depends on inter yarn friction and of course the total amount of force that we are generating and the rigidity of the material. So, simple steps: filament which are very close, then you separate them out. Because of the overfeed that you are giving, there is a possibility that you will get some loops formation, and after that they must be entangled somehow. So, this opening, why is it important? If you do not open, then you may actually land up into a bundle of filaments making, let us say, one loop here. So, this bundle will get some force and it starts bending. If all of them bend together, it is a bad idea. They will open without making any effort almost. So, what we are interested in is that each filament must behave individually to the input of the compressed air, and they do not have to follow anyone. Based on their position in the jet, they should interact and form bend loops, create loops. And then also all these things, if the loops are there and have not been entangled, then they can open again. Without entanglement is useless. This, if it does not happen and bends like this, is bad. And so, you would require some amount of entanglement where the loops are projecting out and there is some area within the yarn which may obviously is not protruding out, but it is still hopefully holding the different filaments at positions which are little more separate than otherwise they would have been. So, you increase the bulk, right. So, you can appreciate that do not try to compare this with this thickness, okay, this is just to show that they are there, but they will be obviously very, very close. So, if we put the stress strain curve, remember the old one, a stretch yarn would look like this. And our material, which is the bulked yarn, this is the air jet textured yarn. So, this is what it says, that there is no stretch. So, it takes up load immediately after straining and it gives all resistance. So, the success of this whole program or this fiber remains is how strong are the entanglements. If entanglements are not so strong, then the modulus will be low. And what will be the bad part is that the yarns will not go back to the positions which they were occupying before you stretched them. Because why would it go back? A loop has been opened, why should it automatically form a loop? How the filament will go back into the same position which it was occupying in the yarn, there is so much of inter-yarn friction. And what is the motivation? When you open a loop, you haven't really stored enough energy. You may have just overcome frictional forces, which have been just overcome. The yarn, in fact, may be more satisfied in a open structure configuration rather than a looped configuration, because a filament yarn was quite stable. Bending, twisting increases the energy. So, the filament would be happy not be in a loop form. So, once you open, there is no way it can go back. So, you may get a permanent extension of the yarn, and therefore, successful yarn would be which remains highly entangled, there are no slippages. If there are slips, that is finished, there is no recovery from that. So, what is happening to this technology and this product? This technology being so simple actually was not adopted commercially in a very big way, despite it being very, very simple to do and simple to understand. The texturing speeds were very low, means you are looking at 10 meters per minute kind of speed they were able to produce. Even at the worst of times, the false twist texturing machine must have been more than 150 to 200 meters per minute. So, you have a beautiful material which is called a fiber or filament, and then you would say, okay, I am going to do a texturing, and then we expect that it is going to take so much time. You say, why is it taking so much time? That means speed is very slow. But now, after some people have understood as to what this whole process involves, they have been able to see the speeds rising from to 300 to 600 and even more. So, is it just something to do with, say, rollers not being there? Obviously, no, that is not true. You have winding machines which could do anything. But one important thing which was there, which is air which is free. Compressed air is not free. You have to work hard to compress it. And if the effect is not good enough, then it is increasing the cost, or you reduce the speed, so the effect is good enough. So, what does it mean by that? A normal air jet, which is called the black box, the length of that may be few centimeters, 2 centimeters, 3 centimeters. How much time the yarn is going to be spending? Would you like to calculate? At 600 meters per minute, you want to run a yarn on a machine through the air jet. Air jet is about 5 centimeters. What is the time that is spent in the jet? What is the time that is spent? Quickly, can you come to some conclusion? Running the machine at 600 meters per minute. the time spent by the yarn in the jet in some seconds, how much? Yeah? Now 0.005 seconds or something similar here and there. Can you imagine what time are you talking about? You can't even appreciate second. By the time you do this, second is over. The other texturing was talking about 0.2, 0.4 seconds. Now here you want to talk about one order less time. How many times you thought you can do any kind of a mechanical process which will be done so fast? So what it means is realization that this process may appear to be very simple, but it is not so simple because you still want a useful product. So higher air consumption means cost. Somebody say, okay, I am ready to pay the cost. Give me the product. Then there is a process property which is called as instability. There we were talking about crimp stability, here I am talking about instability. That you have generated some loops, crinkles, you just put under stress, you say they open. So if you run at a fast speed, you are just not able to do what? Opening of the filaments, loop formation, entanglement, all these things must take place within around this time frame. So one should be always, when looking at processes, should know what exactly is likely to happen. So they started with good enthusiasm, but they probably did not understand all the things, and therefore any acceptable product was being produced at 10 meters, 20 meters per minute, and obviously is not very commercially attractive process. Of course, now the situation has changed. A beautiful research has been done. Large number of people here and there were involved, and they understood everything. Everything means the material itself. From a first statement saying that doesn't matter whichever material you give me, we will be able to do that. We would say yes, of course, but every material has some properties which are different than the others. You must understand how they are correlated, and once you understand, then maybe the material responds better to this technology. And air consumption also for the cost, you like to reduce the cost as well. So you have to design some kind of jets where turbulence could be high, consumption could be less. Otherwise, like you have a compressed air, open the jet and then within few minutes there is no cylinder, there is no pressure, or the machine is continuously running and producing. That is cost. So we look at some of the possible advantages. This is something which they really promoted, this material. Even if currently we look at whatever you are wearing, how many of you are wearing a filament based material at the moment? So it appeared that you had a beautiful false twist texturing process which was giving this and that. You still thought the spun yarn look is a look that you want. If this is true, then they said this is the one which is going to give you. Why? Because surface is really made irregular. Everywhere some loop is jutting out, so specular reflection will never be possible, and it will have compressive feeling, like you have a spun yarn fabric. When you touch, it gives you a little soft thing, because a lot of hair are actually protruding out which you do not see, but you feel. And here you would have small loops similarly protruding out. When you touch them, they will get compressed, but with a little resistance. And so, one may say, well, this is there. Of course, as far as reflection is concerned, it is going to be pretty different. And so, you have a spun yarn look-alike material. So, you make whatever product that you want to make. So, that is one made from filament giving spun-like. Interesting. Considerable reduction, if not total elimination, of snagging. Have you heard this term snagging? Have you heard the term nagging? Yeah. So, that you know. This is something similar, but in different way. There are no languages spoken, but this was felt in early fabrics made from stretch yarns. You have a trouser which is made from a stretch yarn, and you sit down somewhere and then get up. Depending upon the surface, you might find that one of the filament just got somehow entangled with the surface, which had some roughness, and just got pulled out of the fabric. Just pulled out because it does not require too much of a stress to extend it. If it actually came out little bit more from the body of the yarn and therefore the fabric, then it also does not know how to go back to that position. So, it just comes out and stays there, and you see additional loop in a flat nice surface. Suddenly some loops start appearing. If they were uniformly appearing, you may still like as a fashion. If something appears somewhere, something appears somewhere else, it is a problem, because filaments in the false twist textured yarn were independent, they were free, they were not bound, and that was the strength, so that they could stretch and give you bulk. The same thing in a fabric form, if it gets extended, it just stays extended. So, you have a plain surface, and then suddenly somewhere you see that something has appeared, somewhere little more. So, you have a trouser, somewhere you see something coming out irregularly. So, you say, well, please try to make sure that your surface is very smooth when you sit. Very difficult. So, what do you get? Snagging. So, this is a new term, but that is what people felt and called this problem as snagging problem. This is air-jet textured yarn will not snag. Why? It is good air-jet texture. A bad one will do everything, because the loop is really very firmly held. So, you can't pull it out. If you pull means you have to really apply more stress, otherwise not get pull out. If you do not have pull out, then you do not have pull out. So, it will look as it is. Otherwise also the only loops were there all over. As say one more loop comes out, you do not even see. So, they said considerable reduction, if not elimination, of snagging. So, this is my advantage. Elimination of glitter. Again, look at yourself, whatever you are wearing. 99% of the people in the daily life do not wear anything which glitters, shines. Of course, silk is one fabric which you try to use it, but everyday people do not use it, only when they want to show. Or you are, for example, a rock show or somewhere, where the people on the stage and maybe outside the stage, they want to glitter. So, 90% of the people are hardly glittering. So, only faces are smiling, but not the textile, right. So, elimination of glitter, from where the glitter came, and what do we mean by that? Glitter means there is a specular reflection of light, and therefore, there is a shine, and so if you like the shine, it is fine. If you do not, then you can have some problems. In the process of draw texturing, a lot of things happen. Circular filament yarns, they were twisted, there is a compressive stress, they were drawn, more compressive stress, and so what happens is they change their cross section. Let me just see and come back. Like you have, when we're talking about the false twist textured yarn, a POY being twisted starts with a circular cross section. After twisting, drawing, compression, one finds they change their cross section because everything is changing under stress, so they also change. You are bending, they don't mind getting bent. You are twisting, they don't mind getting twisted. And if you compress, they don't mind getting compressed. And what you end up is a large number of filaments would have polygonal cross section without your doing anything, which would mean that a specular reflection will be possible of light, and that is glitter. So, people found that the textured yarns fabrics were glittering more than any other fabric that was available. The air-jet textured, people say, our fibers, yarns, fabrics will not glitter because we are not doing anything. If the cross section is round, it is round. If the cross section is not round, it will not be round. So, if you start with something which glitters, it will remain, it will keep glittering. If it does not, then it will not. Otherwise also, with so much of loops forming here and there, the light is not going to reflect. So, neither you are changing cross section and nor the surface is smooth. So, no glitter. Then the other thing which they talked about was resistance to air permeability. Whether you like it or don't, at least if you want to wear something where you don't want the chill air to just go in, then you may say, well, I am looking at it. But if it is for comparative purposes, compare to the false twist, which otherwise may have been occupying whatever volume that it is still, filaments are free. So, air can pass through from this point to that point easily, while this is relatively more so, you have to displace with more strength. So, that is just resistance. So, let us see, somebody had done some study using the permeability. So, the permeability for the air-jet textured yarn for the same or less GSM can give same permeability. So, you can make the material lighter because otherwise it is less permeable. So, you can do whichever way you want to look at it. Some more advantages, say superior abrasion compared with spun yarn fabrics. You are not talking about filament. So, first you fight with the filament people and you fight with the spun yarns. Superior abrasion. What is an abrasion? Abrasion is that some surfaces are rubbing against each other and some fiber can either come out because of whatever reason, short sports staple length, breaking in one part. But here it cannot slip out because otherwise it is a continuous filament, it is not a short staple. So, anything which resists more obviously gets abraded more based on their rigidities and their tensile properties. The one which give away, like you say, the trees in blizzard, those which are lighter and thinner, they just bend. When it is the force is over, they come back. The ones which say I will not bend, they can break. So, here if there is a loop, before offering any resistance, it just bends. So, if you bend, then obviously you are offering less resistance. So, that is how they can be better. And of course, they are filament, they will not come out very easily. The other interesting thing is you can texturize a blended yarn, or you can make a blended yarn during texturing itself. That is, you pass the viscose filament along with the polyester. What will come out will be a mixture of them. If entangled very well, it is a blend. You can't do false twist texturing passing two filaments together, one of viscose and the other of polyester in the same texturing machine. Neither their extension nor chemistry is related. So, you can't do that. But here you say, well, there is a possibility, just pass them through that and you will do that. Fancy yarns. What a fancy yarn? Well, a fancy yarn is that it could be different colored yarns we can produce, or you can have an core and effect kind of a situation. That means, based on your parameters of control, you can deliberately push some of the filaments in the core and deliberately some outside. For example, you can say polyester, polypropylene, etc. I want most of them in core, and I want viscose coming together, which could be on the surface, and so you have a combined effect. So, you have a core and effect yarns, fancy yarn, different color yarns appearing at different times. You can do a proper programming. So, this color appearance on surface could change, and so you get some interesting products. So, the general structure will be that there can be something which is little more dense, like this kind of an area. This can be considered as the core of the air jet textured yarn, and the other is softer, more compressible, which is the protruding loops. So, these loops are going to give you compressive resiliency. They can compress and come back and compress and come back, but when you stretch in the linear direction, this core and entanglement within the core is going to help it not to open. So, in cases the core is also very loose, then everything will open. So, there has to be some balance of the core and the thing, but the core itself is also expanded. It is occupying more volume compared to if these simple flat filaments were being used. So, all those applications where bulk is desirable, stretch is not, we can use them. So, you want compressive resilience, but you do not want the material to stretch. This is the right kind of material. Use suiting, shirting, dress materials, upholstery, draperies, laminated fabrics, whatever you want, you can make it. A large amount of upholstery for the cars and automobiles could be from the air jet textured material. They do not stretch, they are not required, but good amount of resiliency and bulk could be used. I think that is what we would do it today, that we have some way to define what the air jet textured yarns are, what are the basic principles or processes that are used. Some advantage in application of these yarns is that is what we have done today. We stop here.